Welcome to Web Handling. My name is Dave Roysom. I am super excited to continue our new mini-series on working with operators. In this clip, we will explore just a few of the many ways that bad bosses can wreck operating morale. These not uncommon occurrences are shared from common personal experience. This first story may be apocryphal, but is widely told in many paper mills. It begins with a new boss being given a tour of a paper machine by an old foreman. During the tour, the new boss observes a half a dozen operators sitting at the picnic table. The new boss asks the foreman, "Can't these people be doing something?" After giving it a bit of thought, the foreman went over to the 3,000 foot per minute paper machine and broke the paper. Up jumps all of the workers and they rush over to their stations to help get the paper machine rethreaded and running. The old foreman says to the new boss, "Now they are working." The point of this is that excess capacity is not necessarily a bad sign, as a strict interpretation of Kaizen, Lean, and other popular management programs would have you believe. The paper machine's production is valued at something like $20,000 per hour, while the entire operating crew at most $2,000 per hour. Having excess operating capacity would allow greater attention to operating and quicker return to operation during upsets. The same is true of maintenance. If all maintenance is doing is fighting fires, they will never have time to troubleshoot the cause of the fires. The same is true of work in progress or inventory. If you cut your stocks too closely, you will be late on delivery to your customers. This next story is not a single story, but is rather 1,000 or 10,000 stories that I've personally witnessed. That is, the goal-oriented boss, who, in so many words, says, "Fix it." Of course, we've learned from long experience that we will not be given the time to truly go to school first and then troubleshoot the problem so that an effective remedy list can be made. The assignment will always be on top of all of the other things that we are working on. Of course, we will not be allowed to spend much money, such as maintenance, and especially not to upgrade our machine. Doubly, of course, we will not be allowed to redesign the product because it was such a pain to develop in the first place, and in the second place, we are locked in by customer specs and contracts and codes. Even if the product is unnecessarily risky, and even if the product was not designed for manufacturability principles, that ship had left the harbor long ago. Triply, of course, as we will not be having any discussion with the customer, even if it might be the customer's machine itself that is the major cause. Perhaps the only thing we might be allowed to do is complain to our suppliers in hopes that they might fix our problem without us having to do anything different except for complain loud enough. This next story is also not a single story, but rather 1,000 situations that I've personally witnessed. That is, the boss that expects and sometimes even says the word elimination, usually in regard to customer complaints. However, this is short-sighted and Pollyannish, as I teach in my industrial problem-solving course. Just as the home run in baseball is quite rare, complete elimination of defects or even customer complaints is also quite rare. Indeed, some problems have no known solutions at this time, especially within some of the constraints mentioned in the last slide. Instead, the boss should have recalled his or her business training. That is, economics does not insist on complete elimination. Rather, everything is couched in cost-benefit analysis. If you can reduce waste or delay or complaint by a mere 5% by merely turning a knob, in other words, at no real cost, you would take it. That could be a much better payback than, for example, a whopping 50% reduction of waste that required an expensive rebuild. I was asked, as one of several outside experts, to be part of a problem-solving team for $1 million problem. It is not uncommon. The boss brought in about 30 people into the meeting room, which was standing room only. I do not know what his thinking was. Perhaps if it took one person 30 days to figure out the problem, he could speed things up to one day by bringing in 30 people. It was so crowded that the operators were either left out entirely or at least felt discouraged in making any remarks in front of such a high-ranking group. It was so crowded that me, being only 5'6", could not even see the machine I was supposed to be helping with. Well, it turned out to have a happy ending anyway. After this day-long Kepner-Trago-style meeting ended with absolutely no progress in understanding the problem, much less fixing it, almost everyone went back home or to their normal jobs. All that remained was 3 people, 2 winder experts from totally different companies, and a very well-read chemical engineer from the mill. Together, we figured out a solution that is now standard for most every newsprint mill in the world. Research has long shown that the optimum size of a core of the problem-solving group is only 2 or 3 people, and each has a distinctly different but relevant background. This despite the popular teachings of many management programs that the more the merrier. Yes, large groups at the beginning of the process for data gathering, and large groups at the end of the process for reporting the results of the troubleshooting and then later choosing remedies and making assignments may be helpful. But the best results for the core of the problem solving are with a very, very small group. I teach how to choose this group in my industrial problem solving course. My favorite mix is usually a lead operator and a process engineer who's given the time to work on this hard problem, usually my host, and then myself. Of course, we will be talking with and listening to a dozen other people through the day. But we 3 will be the ones to do the heavy lifting for the troubleshooting, the mechanics of the problem. We 3 will figure out things during a single focused day that dozens of others will not in a year or even ever. This last story is also not a single story, but rather 1,000 situations that I've personally witnessed. That is, working on the same problem, using the same procedures, yet expecting different results. In the pitfalls modules of my problem-solving course, I cover literally 20 ways to know if your project is troubled, perhaps even before you begin. One of the easiest reads of this crystal ball is what I call the Perennial Project. You know the one. It is the baggy webs, or the paper breaks, or the non-woven width variation complaints for customers, or any other of a score of web handling problems that you've been struggling with for years. Quite probably since the machine was installed. Quite probably your competitors are also struggling with the same exact problem, as well as scores of others in the web industry. Progress on these perennial projects require a lot more effort and a lot smarter thinking than was applied previously. You may literally need to go to school first. Then you may need to spend days or even months studying the problem as it shows itself in your plant. Then you may need to figure out the mechanics of the problem that leads to a full effective remedy list, including both pleasant and unpleasant options. This full list, both pleasant and unpleasant, must be given to management for decisions. If managers decide beforehand what can and can't be changed, see the fix it from the previous slide, I would look for another project or even another job because success is unlikely. There are 3 starting points for a more detailed discussion of problem solving. The first is my Industrial Problem Solving book that is a good companion to my Industrial Problem Solving course of the same name. The second is the must-have 750-page Web Handling Handbook written by myself, Tim Walker, and Dr. Dylan Jones. This is where you would turn for the sciences of web handling, which can guide you in more effective problem solving by not having to reinvent the wheel. The caution here, however, is that science is never complete, and sometimes not even correct, at least for some odd situations, just as we've seen in these stories. Last but not least is my award-winning and trademark Web 101 class that has been taken by 5,000 people just like you. Here you will learn about web handling, winding, comment, converting operations like slitting, as well as a good sprinkling of problem-solving techniques. Thank you so very much for joining me in this mini-series on working with operators. I hope these personal stories from the field will inspire you in new ways to think about problem solving. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.